All right, what we're going to talk about is we're going to talk about turning a single line diagram, or that's what I call it, but a ladder diagram, into a wiring diagram. So we have an example here, and what is my first mistake in this drawing? What is my mistake that I've made in this drawing? Everything that's in the control circuit should be in red. Everything in the control circuit should be in red. So this whole line here with the stop, the start, the holding contact, and all that should have been in red. Okay? So the first thing you need to remember is that everything that's control should be in red. The control circuit are the little tiny wires. The power circuit are the big heavy wires. Okay? Now, let's say we know that from this drawing we can tell that this single coil here is a relay and it has two contacts. One in the power circuit and one in the control circuit. So that's a single relay. So let's draw a picture of a coil that has contacts. And most of them, a lot of them I should say, have 3 normally opens and 1 normally closed contacts. We're going to call these pins because on your board you have pins sticking up for every connection. And how can we tell by looking at the board where the coil is on a relay? Which 2 terminals go to the relay? The coil. Coil of the relay. The coil of the relay is a wound piece of wire. So we'll have a steady state resistance above 0 and below infinity, right? So let's say you check these pins and several of them are infinity, they're open, and some of them are 0, like the normally closed, it will be almost 0, or maybe 1 ohm, or 2 ohms, or 3 ohms. If it's 1, 2, 3, 4, 5 ohms, that's shorted together, okay? That's a normally closed contact. Infinity, normally open. But when we go across the coil, we'll see a steady state, say 20, 30, 40, 50, 150 ohms, depending on the resistance of the coil. So that's how you can tell a coil. That's called wringing it out. You wring out the coil to find out what connections you have. So this relay has 3 normally open and 1 normally closed, and the coil. So it's got how many pins? 10 pins. The coil has 2 also. Okay? Now, so that's a coil. I mean a relay. And we've got everything except a push button. We need a push button, right? How do we show a push button? How's a push button drawn? How's a push button drawn? Open your industrial motor control to the 2nd chapter and find the symbol for a push button. How's it drawn? I'm going to hit a pause for a second. So the normally open looks like this, and the normally closed looks like this, right? Okay, so let's draw a normally closed. So there's your stop. Now, some buttons are dual element push buttons. Does everybody see the symbol for dual element push button on here? Because most of our boards have dual element push buttons. And it looks just like this. So in other words, if you push this thing down, it goes to the normally open and closes it. When you leave it up, it's the normally closed. So it's both normally closed and normally open, right? So let's draw 2 of those. And we're going to come out and put a terminal on it. So now we have, what is this part right here? That's a dual element push button. This is a dual element push button. Everybody agree with that? Okay, so now you have 2 dual element push buttons, right? But one has a red head and one has a black head, right? Which one is always stop? Red is always stop. Okay? If you bring a board up and you have a black push button wired as a stop button, you have made a mistake, a basic fundamental mistake. Okay, what else do we need? So we need two push buttons, we need a relay, and we need a motor. Now, motors often have 4 pins, but we're going to assume that this is a simple 2-pin motor. Now, if it's got 4 pins sticking out, it's probably AC/DC universal motor, and it's got the armatures coming out and the field windings coming out. Or it could be a PSC motor, and the start winding is coming out and the run winding is coming out. And to reverse either of them, you reverse one winding, but not both. So there's the first thing about running a reversing system. Okay, so we're going to say that we only have a 2-pin motor, just to keep it nice and simple. And we always have a pin on our board that we call L1 and L2. And we're always going to put the grounded terminal. If you look at your project board power cord, if you look at it, one of these 2 wires has ribs on the outside. That is the grounded terminal. The other one is the hot terminal, or the energized terminal. Okay? And we always put the grounded terminal on L2. Okay? Now, so now we have L1, L2, 2 push buttons, and a relay, and a motor. That's all we need for this project, isn't it? Now, we're going to draw this similar to this, except we're going to figure out where the wires go. And now, we're going to use red and black again to identify which ones are power circuit and which ones are control circuit. So let's do the power circuit, because it's very simple, right? L1 goes to a contact, a normally open contact. Okay, L1. I got that, right? Where does it go from there? It goes to the other side of the contact to the motor. Other side of the contact to the motor. Where does it go from there? It goes to the overload heater. Now, we don't have an overload heater drawn on here, but after that, it goes back to L2. That's the whole power circuit. Everybody agree with that? Now, what if I want to start drawing the control circuit? What do I start with? Stop. Exactly. So we want to go from L1, except now, let's say that this one has a black face, and that this one has a red face. So if that one has a red face, what is my stop button? The lower one. Now, in my stop button, I've got both a normally open and a normally closed. What do I want? Normally closed. I want a normally closed. So I want to go from here to the normally closed. Is that correct? So I've now got my wire to go here. Everybody see that? Where does it go from there? It goes from there to the start push button. I can figure that out. What part of the start button do I want? I want the normally open. I'm just going to go here up to here. Where does it go from there? We're just going to go straight across for the moment. It goes to the coil, right? So we're going to take a jumper from here to the coil. Then the other side of the coil goes to a normally closed overload heater contact. We don't have actual overload heaters on the board, so we're going to skip that. We're going to go right to L2. So we're going to go from the other side of the coil up to L2. Everybody okay with that? Now, what have we left out? A holding contact, but it is parallel to the start button, is it not? Everybody see that? So we need a normally open, and we need it parallel, very simply, to a normally open. If we just made a wiring diagram, now what other thing could I do to make this even easier to wire? How about if I numbered my wires? Now, I want to tell you that this red wire, that's wire 1. But this black wire coming off the same pin now, coming from the same pin, but the one going to the power contact is L1. So this one is L1. This one is 1. What do we call this wire right here? Because we number the control circuit first. We call this 2. But there's two wires, right? There's this one and the one that goes over to the jumper. That's 2 also. So what number do you think this wire is? Both this wire from here to here and this wire from here up to here, those are both number 3. On motor starters, there's a holding contact identified by, it'll show a contact symbol, and it'll show a 2 and a 3. Now you know why. Because in 3-wire control, there's always a 2 and a 3, and it's always parallel to your holding contact, maintaining, sealing, or pallet. Okay, so now, if I number these wires, let's say I'm going to call this one 1, right? I'm going to call that one 2. This is a 2. This is a 3. It's going to the holding contact, right? It's getting easier to put these wires on really quickly now, isn't it? The object of having a wiring diagram is, so let's say you finish a project early on during the hour, but you're stacked up in line to get a second project done. You get it all wired up, and you've got your wiring diagram. But now you have to tear it apart at the end of the lab and put it back on the shelf. It's okay. You've got a wiring diagram. You can rewire it in about 15 seconds if you've got a wiring diagram. If you don't, you've got to follow the steps of working through this all over again. It might be 10, 15 minutes, put it back together. A wiring diagram is a time-saving device. It's simplifying the ladder diagram into this wire goes here, this wire goes there, this wire goes there, this wire goes there. And if you can see it, you can do it. And what else have you not been able to identify? You have the red push button and it's got 4 pins. What are on those pins? Normally open contact and normally closed contact. How would I ring that out with my meter? Find the 2 that are always open until I push the button down. And then it goes closed. That's the normally open. What's the state of the button? What's the state of the button? A natural state of the button before you push the button in is how it's named. Normally open is open before you touch it. Normally closed is closed before you touch it. The inactivated position is how we name things. Okay? We don't say that a push button closes or opens. It changes states. I may ask you that when you come up sometime. What do you call this when I push this button? Are you closing that contact? Well, it is closing the contact, but we're changing state. Okay. I hope that was helpful. And in less than 15 minutes,